Dear students, today my class is 7th class Max, chapter 12, Symmetry Exercise 12.1. Before going to this class, please subscribe King Classroom for Max and computer online classes, or type in YouTube search DSN Raju classes. My channel will be available. Now coming to the class. 7th class Max chapter 12 Symmetry exercise 12.3. Okay, first problem. Name any two figures that have both line symmetry and rotational symmetry. Solution. The line symmetry is the imaginary line where you could fold the image and have both halves matching exactly, whereas rotational symmetry is when an object is rotated around a center point turned by a number of degrees and the object appears the same. The order of the symmetry is the number of positions the object looks the same in a 360 rotations. Triangle and square are two figures that have both line symmetry and rotational symmetry. Okay. Second problem. Draw wherever possible in a rough sketch of first one a triangle with both line and rotational symmetries of order more than one. At second one, a triangle with only line symmetry and no rotational symmetry of order more than one. A third one, a quadrilateral with rotational symmetry of order more than one but a line symmetry. Fourth, a quadrilateral with line symmetry but no rotational symmetry of order more than one. Solution. First one, an equilateral triangle has both line and rotational symmetry of order more than one. Here the line symmetry like this. Three lines is there. Line symmetry, rotational symmetry, same. Rotational. This is the rotation and this is the rotation. Second one, an isosceles triangle has only one line of symmetry and no rotational symmetry of order more than one. Here isosceles only one line of symmetry and rotational symmetry. There is no rotational symmetry because the isosceles triangle two angles are equal. Okay, remaining angle is not equal. Two sides are equal, remaining sides are not equal. Okay, third one. A quadrilateral with line symmetry may have rotational symmetry of order but not more than one. Hence, it is not possible to draw. Okay, a quadrilateral with line symmetry may have rotational symmetry of order 1 but not more than 1. Hence, it is not possible to draw. Okay. Fourth one, a trapezium is a quadrilateral that has only one line of symmetry but not rotational symmetry of order more than one. Here line symmetry is like this. Rotational symmetry, it is not possible. Okay. Third one, if a figure has two more line of symmetries, should it have rotational symmetry of order more than one? Okay, solution. Rotational symmetry is when an object is rotated around the center point, turned and number of degrees and the object appears the same. The order of symmetry is the number of positions that object looks the same in 360 degrees rotation. Yes, if a figure has two or more line symmetry, it has a rotational symmetry of order more than one because every line through the center forms a line of symmetry and it has the rotational symmetry around the center for every angle. Example, an equilateral triangle has three lines of symmetry. It shows the rotational symmetry at angles 120 degrees, 240 degrees and 360 degrees. Hence the order of rotational symmetry is also 3. Fourth one, fill in the blanks. These shape, center of rotation, order of rotation, angle of rotation. Square, rectangle, rhombus, equilateral, triangle, regular, hexagon, circle, semicircle. Solution. Center of rotation. In case of a polygon, the center of rotation intersecting point of diagonals, and in the case of circle, center of rotation is the center of the circle. Okay. Order of rotation. In case of regular polygon, order of rotation is always equal to the number of sides. Okay. And in the case of circle, order of rotation is infinite. Angle of rotation. In the case of regular polygon, angle of rotation is always equal to the measurement of one angle, and in the case of circle, angle of rotation is at every point. Okay. Now the table. Shape, center of rotation, order of rotation, angle of rotation. Square, intersecting points of diagonals, order of rotation 4, angle of rotation 90 degrees each. Rectangle, intersecting points of diagonals only 2, order of rotation is 2, 180 degrees. Rhombus, intersecting points of diagonals 2, order of rotation, angle of rotation is 180 degrees. Equilateral triangle, intersecting points of medians midpoint 3, order of rotation, and angle of rotation is 120. Regular hexagon, intersecting points of diagonals is 6, angle of rotation is 60 degrees. Circle, midpoint of diameter infinite, midpoint of the diameter infinite. At every point has the angle of rotation, order of rotation is infinite. Semicircle, midpoint of the diameter, only one of order of rotation 360 degrees is the angle of rotation. And fifth one, name the equilateral, name the quadrilateral which have both line and rotational symmetry of order more than 1. Solution. To solve this question, we have used the concept of line symmetry and rotational symmetry. The line of symmetry is the imaginary line where we could fold the image and have both halves match exactly, or where the both images are replicates of each other. Okay. Rotational symmetry is seen when an object is rotated around the center point turned by a certain number of degrees, and the object appears to be the same at these angles. Okay, these angles object should appear same. The order of symmetry is the number of positions the object looks alike in a 360 degrees rotation. Square has both line and rotational symmetry of the order more than 1. Okay, coming to the sixth problem. After rotating by 60 degrees about a center, a figure looks exactly the same as its original position. At what other angles will this happen for the figure? Solution. When an object is rotated in a particular direction around a point, then it is known as rotational symmetry, also known as radical symmetry. Rotational symmetry exists when a shape is turned and the shape is identical to the origin. If a figure looks the same as the original at one angle, then it will look the same as the original on all multiple of the angles. Thus, if the figure looks the same as its original position by rotating an angle of 60 degrees, it will also look the same by rotation at the at an angle of 120, 180, 260, 240, 300, 360, as these are its multiples. Okay. Seventh problem. Can we have a rotational symmetry of order more than one whose angle of rotation is 45 degrees and 17 degrees? Solution. When an object is rotated in a particular direction around a point, then it is known as rotational symmetry, also known as radical symmetry. Rotational symmetry exists when a shape is turned and the shape is identical to the origin. If the given angle is a factor of 360 degrees, only then the figure will have rotational symmetry of the order more than one. First one, 45 degrees is the factor of 360. So the figure will have rotational symmetry of order more than one, and there would be 8 rotations. Second one, 17 degrees is not a factor of 360 degrees. So the figure will not have rotational symmetry of order of more than 1. Thank you to complete watch video. Thank you students. Like the video, share the video, subscribe the channel with your friends. Thank you.